Our last section in chapter 4, pretty quick one. You just fly right through this stuff. Just catching the notation and getting it down. There's not much. You're just kind of just knowing what's up. Just knowing what's up. So we're going to keep going. We learned how to multiply and divide complex number and the complex numbers that are in the form, the trigonometric form. And now we're going to use this to see how we deal with exponents. And that's going to be DeMoivre's theorem. Let's pronounce DeMoivre. And I'm mispronouncing because I don't speak French. That's my Americanized version of how you pronounce that. So somebody that actually does speak French is probably like, oh, geez. You're trying to teach us how to... Yeah. I know a little bit about math. I don't know anything about French. I know there's no possessive, right? This thing right here. It's about the one thing I do know about French. That's not allowed. They don't have that. That's an Americanized. Okay, we're doing math, right? We're doing math. Okay, so let's build this up. This isn't going to be a proof, but I think this really kind of shows you what's going on. So we start off with our general form. Z is equal to R cosine theta plus I sine of theta. Actually kind of said that wrong. Now what we want to know is what's Z squared? And then we want to know what's Z to the third, and Z to the thousandth, and Z to the millionth, and how we're going to go through and do this. So what's going to end up happening is we're going to write this twice. Oops. I'm going to write this twice. And we're going to use, right, squared means write it twice and then multiply that crap together, huh? And we're going to use that multiplication trick. So we got that Z squared is equal to, and we look and we're like R times R. So we get R squared. And then we have our cosine of the first plus I sine of the same freaking angle. So how do we deal with it? When we multiply, don't we take our angles and we add them? So if you have one theta and then you add another theta to them, how many thetas do you possibly have? You have two thetas. You have two thetas. So it looks like Z squared is just going to be equal to R squared times cosine of 2 theta plus I sine of 2 theta. Please don't use any double angles here. Just leave it how it sits. And if we were to keep going through the pattern, I won't make you watch me do it all, but if we're going to go Z cubed, it's just going to be, we're going to take our radius and we're going to cube it on up. Huh? That's a 3. That's a 3. Let's make sure you can see it's a 3. And then we get cosine of plus I sine of the same. And that's going to be, oh yeah, you guessed it, 3 of the thetas. So if we were to continue going, just keep doing this thing, we're going to say Z to the nth, and saying n is a positive integer, or a natural number, a whole number that's positive. We can say that this is going to be equal to R to the nth power times the quantity of, right, this big bad boy here. And we're just going to say that it is n times your theta. And this, my friends, is DeMoivre's theorem. There it is. It's saying if you raise any complex number to a positive integer, we have a little shortcut. It works through just like this. And now let's just go through and let's just take a peek. Here it is. There's DeMoivre's theorem written out in all its glory. If Z is equal to R times the quantity of cosine of theta plus I sine of theta is a complex number and n is a positive integer. I swear I'm repeating myself, but I'm trying to drill it into the head. Then we got this stuff, right? Z to the n is equal to this. Now beware. Sometimes we like to write it in this manner. Sometimes we like to write it in that manner, being able to see that as well. So we're going to get just a few short videos through here. I'll do a couple of examples, and then we're going to be done with this because we're only doing half of this section. I'm going to leave out what's called the nth root of a complex number. It's just long, tedious, and I don't really feel like going through it. I learned it in grad school. I didn't actually learn this even as an undergrad, so I think I'll leave you all alone about it. Maybe, and who knows, maybe it'll be semesters down the road and I reuse this thing and I'm like, no, now I do it because I'm a big old jerk. But if you're in fall of 2020, you're good to go. Now spring of 21, I don't know. We'll see. All right. I will see you in the next one.